Greetings everyone, this is not an expert here back again with another video. Today we'll be solving problem number 21 and the difficulty it's been rated at is easy. This problem was asked by Snapchat, but I've seen it in interview experiences for Google, Amazon, Goldman Sachs, Microsoft and so on. So it's a pretty famous problem and let's just get down to it. So given an array of time intervals which have a start time and an end time for classroom lectures possibly overlapping, find the minimum number of rooms required. For example, given this list, the answer should return to 2. So this is a pretty famous problem and it goes by a variety of names such as the meeting rooms problem or the railway problem, in which all we have to understand is what's the number of um, rooms which we need to allocate in order for us to not have any issues whatsoever. So basically, in another way, you can just think of it like this, that you just want to find out what are the maximum number of overlaps which are happening. So if you have this list over here, which has start time and an end time, you can see that there's an overlap between lecture A and lecture B, where you have 30 to 75 and 0 to 50. So there's a overlap from 30 to 50. And there's another low overlap between the 30 and 75 and 60 to 150, which is basically from 60 to 75. But there are no other overlaps. So in total, the number of overlaps which are happening are 2. So in one way, the number of meeting rooms that you require in order for you to accommodate all the classes is 2. Cool. So fortunately, we were able to find this problem on lint code and we'll be getting into it. You can pause this video and try to go through the description yourself. It's pretty simplistic, and but we'll be just jumping into it, right? So there are a few ways of actually handling this solution, and one of the ways is that you sort of convert this interval list, which you're already getting as a parameter, into two lists, which are the arrival list and the departure list, or the starting list or the end list, right? So let's just say it's the starting list and the end list for other people. Um, and what's going to happen is that if you notice before, we would have to sort this entire thing before we move on to the solution, right? That's the first thing which we'll have to do. And when you're sort of doing a lot of pre-processing before you sort of move on with the problem, it sort of does not give the correct output, and not the correct output in the sense that you're not solving the problem, you are, but to the interviewer, it might seem that you're munging the data too much in order for you to get your way with it. Um, and that's not really required. So the way we'll be using this is by actually using a new data structure which is called a heap. If you don't know what a heap is, or rather what a mini heap is, which we'll be using in this case, I would suggest that you can Google it or check the link in the description below. But it's a pretty simplistic data structure, to be honest. Most people are pretty scared of it, but it has a variety of applications where it's used. And one of the application where I sort of like to use it a lot is just to find out, what's the minimum element and, when you have a stream of elements. But over here, what we'll be doing is we'll be using it as a min heap. And the best part is that we can get the min at an O of 1 complexity, right? That's the main part. Basically, that you have a parent and you have several children, um, and the children are always greater than the parent. So if you don't understand what I'm saying, you can pause this video, go through the description, read up on it. But we'll be getting into the solution itself. So we'll start with the base condition, and the base condition is that if there are no intervals, we return 0. The other thing which we have to do is we have to make sure that the intervals are sorted. And the way we'll be doing that is by basically using something called as a sorted function in our Python module or Python language rather. And if you're not familiar with this, it's pretty simple. If you have seen in any other places, the way you use sort, basically you give a parameter as key, and the key is used in order for it to compute the ranking of the entire list. Right? Pretty simplistic. Today we'll be using the sorted, but the key is not going to be simplistic. It's going to be a little bit complex. And basically what we'll be sorting on would be the start time, which is pretty obvious, and then the end time. So in case if you have a list which has 0, 10, and you have 0, 5, we would want the 05 to come first. So that's the reason why we're putting the end time as well for the sorting computation. And let's just move on with this, right? So this entire operation is n log n. Um, and let's get on to the actual implementation of the heap. So basically, a heap can actually be represented as an array, uh, and you don't need to really implement it in any other way. Um, but we need a array and we need a count. Cool. So the way you sort of, if you're not familiar with this library, it's pretty simple. All you have to do is you just have to use this function as a wrapper whenever you do a heap append, right, or a heap pop. So we'll be using these functions, and the way they sort of work is that whenever they perform all these operations, they also make sure that the heap is heapified so that we don't really have to worry about it. Um, and by the meaning of heapify is that, the value would be the top value would be the minimum value. Um, and we'll be containing the end times over here since it's an array and it's going to be an array of values. We're just going to contain the end times of it. Cool. So the way we're going to progress with this is we need to iterate through all the intervals. So let's just say for it and sorted intervals, um, let's just pick out the start and end because it'll be easier for us if we do that. Let's do that. Cool. And the way we're going to go with this is that if you have a heap, right, and the top value, which is the minimum value, is actually less than the end or the start time rather. If that's the case, then you want to make sure that the heap is popped. So we do heap pop here. And if you didn't understand what this is, let's just comment it out. We'll use this a little later. Let's get down with a better approach where we just sort of append all the values inside our heap first. So all we have to do while appending a value inside our heap, instead of doing heap, we just have to do heap push and pass in our heap structure and the end value which we found so far, right? So we are going to contain the end values as I mentioned before. And the reason why we contain the end values is basically it's going to help me determine whether there's an overlap or not. And every single time I have an end value getting pushed inside my heap, it's going to be the minimum value, the least value it's found so far. And whenever I sort of iterate through the entire sorted intervals, whenever I find a value where the start, right, like this entire thing, where on the top of the heap is actually less than equal to start, that will basically just mean that that value is no longer required for me. If you didn't understand, let's take this example. Just 1 second. Okay, so this seems to be sorted. And the way we're going to progress with this is that, at the very beginning, you can see that, you know, let's just give it all of these A, B, and C. You know that A is going to be pushed inside your heap, which is correct, which has no problems whatsoever. But when we go to the next item, we can see that there's a 5. It's starting at time 5, and this A is actually ending at 30. So that means that you need 2 rooms, and when it needs 2 rooms, we just push it inside our heap, right? Let's say that this was not that. Let's say that this was 35 and 40, and let's just remove this guy. We can say that when A gets processed and when we go to the next element, you can see that 35 is actually pretty greater than 30, right? So that means that there are no overlaps. So we can sort of construe this as that this is no longer required and we need to push in B instead, right? And that's what's happening over here as well. So we're popping out those values which are already done, and we keep on pushing the values which are already there. And when you sort of use this entire structure, you can see that at one point of time, the length of the heap which we've got so far is actually the one which is sort of helping us understand what's the max value which we've encountered. So we just maintain that inside our count and we just return our count, and that's it. So that's the entire implementation. All we've done is, if you didn't understand heap push, one more time, It's just an append inside our heap. It does it in place, so we don't have to do heap equal to heap push. It's doing it in place. Um, and when you sort of construct the entire heap structure, you can understand all those values which need to get popped out or which don't need to get popped out. Um, and that's it. So let's just do a few prints. So that's one more time. It's a little bit easier for everybody to understand. So let's do start and heap and um, I think that's all it's required. So let's run this. So this is our input, and as you can see, um, the file it's getting sorted in the correct order, which is good. So you have this guy coming in first. If you don't mind, I will sort of put one more here so that's easier for me to explain this. I am so sorry. Let's just we need to print the sorted elements, so let's just do this. You have start and for I and sorted intervals. Hopefully this should run. This is just for printing purposes. Oh, unfortunately it's not running. Let me just have a look at it. Let's just sorry dot and double and let's run this test. Cool. So we have a sorted list over here, or sorted list of intervals, and we are starting with 5 and 6. So 5 and 6 is good. 6 gets pushed inside our heap, and next time it sort of encounters anything else, that value needs to be greater than 6. The start time needs to be greater than 6. So, but that's not happening here. So we have 5 and 10, but the value of 10 also got pushed in because it's sort of denoting that there was an overlap at that particular moment of time. Then when we encounter 10, we use the 10 to understand what all values are important for us. So 6 has gotten processed, so we don't care about that, so that gets popped out. Something similar like that for the 10 as well, it gets popped out as well. And the only value which is sort of required is 30 at that particular moment of time, right? Because there's no overlap here whatsoever. But there is an overlap at 15 and 20, so you can see that overlap happening. And that overlap basically is determined by the start time getting compared with the minimum end time which we've encountered so far, which is 30. And if that's the case, it sort of pushes it. And you can see that during this push, what's happening is that 20 got pushed at the top of the heap, and that's just the heap property. It's a min heap, so that's why it got pushed at the top, and 30 is next to it. So whenever we encounter anything else, all those values which are, all those end times which are after the start time of any other element, those are just redundant for us, so we just pop them out. And that's it. And throughout the process, we're just maintaining one more count, which is just counting the maximum length of the heap which we've encountered so far. And then we just return it. Cool, let's just run this one more time. Hopefully it should run. Output is same as expected, and let's just submit it. Hopefully it should run. And it does. Cool. Again, if you didn't understand this entire thing, you can leave it in the comments below and I'll try to answer them as much as I can. The reason why I've gone with a more heap approach and not the approach which is given in Geeks for Geeks or rather anywhere else, where you sort of push all the starting times and end times inside one more list and do all those manipulations, is just because it's a little tricky to handle all those things. And for most of the coding problems, you want to not munch data too much because you want to deal with only those memory values which are required for you. And you don't want to get memory space exceeded problems and all. There can also be one more case that people could say that you cannot manipulate this entire intervals list, which will just pose a very big problem for you. And the only way to solve that in this case would just be to use a simple heap, and that's it. Cool. So that's it for this video. I hope I've helped everybody understand how heap can be used in this solution. Again, if you like this video, do give a like, and if you're subscribed, you're awesome. We all know it. And Have a very nice day.